Hi, this is Clinton. Today we're talking .NET development. Specifically, we're going to talk about modularity, scope, code organization, tools within Visual Studio that can help us do this. There are a ton of tools. There's no way I can cover everything within a 20-minute video. So I'm going to touch the basis, but we're literally introducing the concepts of functions and methods today, as well with variable input parameters and scope of variables and those kind of things. So lots to cover in 20 minutes. So we're going to go fairly quick. If you need to pause, rewind, and rewatch, then go for it. So the focus of what we're going to be talking about today is the ability to separate your code into independent structures within your entire context of your program. And that is the start of object-oriented programming. And the idea is we're going to look at functions, subroutines, methods, procedures, and what their context is within the C# language. When do we separate code? When do we create algorithms? And then lastly, the audience that we're looking for are literally for brand new programmers just learning to program, not for people who have been programming for a while, but brand new people, computer programming students in their first year of college or university, and people who are learning object-oriented programming for the very first time. That's the focus of this beginner level lesson. So the idea, the general concepts is we want to avoid repetitive tasks. So anything that you do multiple times, we're going to try and build routines such that we don't have to do that. More specifically, avoid repetitive code. So if you find yourself copying and pasting code, then stop, because if you have copy and pasting code to multiple locations, you are introducing room for error, hard to maintain, and you're being repetitive. So not a good idea. The other thing is if you find yourself making variables for like number 1, number 2, number 3, number 4, well then there are control structures and collection items which are better for that, such as arrays. And those kind of tools such as collections, lists, arrays, stacks, queues, and those kind of things are all fundamental parts of how we can do multiple objects within an object-oriented programming method. And the last and probably the most important is ensure that your code is easily maintained. If you need to make a small change, it is important that the way you've coded it means that change only has to happen in one location. If you find yourself making the same change over and over and over again in many areas of your code, likely there's a better way to do it. Functions, methods, subroutines, procedures, literally in C#, they literally all mean the same thing. In different programming languages, they have different context, and we do have slightly different context within the C# language, but it's so muddled and so different that when you talk to other people online, you talk to other people, they literally use the names interchangeably. But in general, they're all segments of code which you name, and then you can call them back later by that name. So you can actually put a bunch of routines and say, hey, let's call that do stuff. And then later on call do stuff, and it'll go do all that stuff, for instance, okay? So the names are fairly interchangeable, and these names meaning functions, methods, stored procedures, and subroutines and procedures, not stored procedures. Those are database. But generally, the concept is functions are procedures which execute code and return something. So they return a value or an object or a control or something. A method or a subroutine is also a procedure, and they execute a segment of code, but they don't return anything. And that's why we typically use the word void with them, because they mean they don't return anything. They return the void, okay? All of them are procedures. So procedure is sort of the general term up and above functions, methods. Subroutines is a term that's typically only used within languages such as Visual Basic, Pascal, PL, and some of those other languages. So for the most part, we're typically just going to use the words function and method. And when we're talking about them generally, we'll use the word procedure. But generally, they're all the same thing, okay? Event handlers are another special breed of methods, and the only difference is they're typically associated with an object's event, such as a button click, text change, those kind of things. The functions come from the mathematical term function. So the idea that you have some function which takes an input parameter of x and returns a value. In mathematics, that's typically referred to as y. So y equals 4x plus 2 would be the linear equation. So we can turn that y into a function of x. So as we change x, the value of the function of x would change by having that as an input parameter. And in the long and the short is this is an equation that you give a value and you calculate the value of y. In simple terms, this is a function that receives some input and returns a value, okay, a single result. So in programming, we replace that function with a segment of code or an algorithm, and it will return a single result as a function. A method will do the same thing, but just doesn't return anything. And that single result can be anything. It could be a string, a text box, an integer, a decimal, a double, an object. It could be even be a text box. Like, it's going to return a single thing. And it can also return a collection, so something like an array. And although an array contains many, many values, the array is a single object itself. And that's sort of the idea. So when you end up copying and pasting code, stop, because there's likely a better way to do it. So with the use of collections and functions and methods, you can simplify your code and reuse code over and over and over again without having to repeat the code. And that's really what it is. Overall, functions will use up less space, make it easier to write, easier to maintain, and most importantly, if a change does have to happen, that change most likely only needs to be changed in one place versus having to do it in 5 different places and introducing the potential for human error, and you missed one of the changes. And now your program has logical errors that are usually very hard to debug because you got to find where the problem is. Okay. So here's an example of a basic function. Comes with 5 parts. The first part is the access modifier. So the word private is the one that's used in this case. You'll see public, static, and you'll see a bunch of other, protected is another one. You'll see that essentially just says what other parts of my application can access this code. Private says in the Windows Forms application, private says only objects within this form itself can access this code. If I created multiple forms on my Windows application, only the objects in the current form or the procedures within the current form could call that function. The second is the void. And in this particular case, the void can be replaced with integer, double, string, text box, class object. Can be replaced with anything. It's essentially the type of variable that's getting returned. And in beginner programming, they typically have void, integer, double, decimal, string, etc. As we get more advanced, we will have that returning arrays or returning text boxes or control objects or class objects as we learn those concepts. The next is literally just the name of the method. So when I give it a name, do stuff, then later on I can refer to this code and say, go execute do stuff. And that's it. The fourth part is the brackets. And the brackets, if they're empty, that means there's no data coming into this function. But if there are parameters within those brackets, you would define the type of the parameter and the name of the parameter. And that would be set up with local scope, which we'll talk about in a minute. The fifth part of this is literally the code itself. And the curly braces define a command block. And that command block has significant impact when we talk about the scope of variables in a few minutes. So some examples. So some of the important things that you're going to do. So setting defaults on a form is something you're going to do more than once. So when you first load the form, you want to set all the default values so that everything is fresh and clean when you first start. But then you might do some calculations, you might do some stuff, and then you're like, okay, I'm done with that. Let's start again. You don't want to have to close the program and reopen it again, so you want like a reset button. So we'll have a reset button that literally calls set default. So I've already given you 2 examples where the same code would have to execute twice. Well, you're not going to write that code twice. You're going to create a function called, or a method in this case, called set defaults, and just call it from the different locations. So on form load would be an event that you call it, and then on reset button click would you also call set defaults. So you're reusing the code from many different sources. So that's a really good example. Another one is a function that returns something. So something like convert Celsius to Fahrenheit. So it's going to accept a variable of type double, We're going to store that as the variable c. We're going to create a variable double f, and you do some mathematical calculation, being careful that integer math versus double math are different. So we've converted all those to doubles. And then we're going to return a value. The double in the definition or the declaration of that function means that this function will return a double. If that return type is anything but void, that function must have a return statement, and it must return something of the same type. So f is a double, I'm returning it, and this whole entire function is returning a double. You can then take another variable of type double and assign it the value with the single equal sign to the result of this function. We'll show you examples of that in a minute. Okay. When we talk about the input parameters for these functions, there's two different ways. The default and by far the most common way is by value, and this is the default value method. So there's an error in this code here, and the error is these two lines should be reversed. These two text box input lines. Don't ask me why I did it. I just goofed for a minute. But the idea here is that we have a private void function called calc temperature, and we're going to execute that from somewhere. But when that procedure executes, we're going to set an input value of 20. Then we're literally just going to, if we're going to run this line first, output text is equal to converter C to F, and we're going to send that value, which is going to be 20, into the function. Now, when we send it by value, which if you don't do anything, that's the default, we're actually taking the value that's input variable and sending the value in. We're not sending the variable itself, we're sending the value in. So the value gets put into the variable c. So if I end up changing the value of the variable c, it has no impact on the original value of the variable input value, okay? Because I'm taking a copy of that value and sending it in. And I can do whatever I want with it. So I'm going to do the calculation here of calculating the Fahrenheit, but then I threw a line in here just to change c to see what happens. So after I've executed this function, it's going to run this line. As I said, these two lines should be reversed. So if it runs this line, then the input string will output, the input value will output afterwards, and it will still have the value of 20, even though I set C to 25 down here. So let's look at the other way, which is by reference. So you see this is part of the pointer section in C++ or in original C and those kind of things. It's sort of the C# equivalent to this, but it's far simpler because C# takes care of a lot of the memory allocation and all that stuff for you. So the idea here, again, these two lines should be reversed. Okay, we're going to set the input value to 20. We're going to run this, execute this function. The difference is this function is going to receive the reference to that variable. Okay, so we're going to send in a reference to the input value. Now the reference is pointing to the memory location where the value is stored, like your physical memory in your computer. So it's going to send a reference or the memory address of where it's stored. And this will be, so the reference for C will be a reference to the same memory location. So what happens when two variables point to the same memory location, if you change the value stored at that memory location, the value of both variables will change. So in this case, when I've sent in the reference, when I change the C here to 25, I'm changing the value stored at that memory location, which means that the input value, which happens to point to the same memory location, the value in that location has changed, so the value of input value has changed. So the input box, again, with this line executing after the previous one, would actually output 25 because it changes. This is a workaround method that is used very often in order to have a function return multiple values, because by definition a function only returns one value or object, where in this case we're actually changing a variable somewhere else so we can in essence return multiple values if we need it. So sort of a workaround method, it seems like it, but it works and is used all the time in practice. So the last concept I want to cover is the concept of variable scope. So there are three main types of scope for variables. Global scope, which is the values of those variables are available just about anywhere. Local scope, where the values of the current procedure and the child code blocks. So if you define a variable within a function, it's only available within that function and any child command blocks within that. Okay, and then block scope is a variable that's defined within a block of code, not necessarily a procedure, but a block of code. And that has block scope, which means it's only available within that small block segment. So when that segment of code is complete, that variable is no longer available. And we'll show you that by example. Okay, so let's go ahead and flip over to Visual Studio. And I set up this really simple example, which is exactly the code I was doing in the window a minute ago, where I have a numeric up-down box that you put in a Celsius temperature. And I have two buttons. One that's going to call a function where the function is run, where the variable is sent in by value, and the other one is where the variable is sent in by reference. I've output the values before I execute the function and the values after I execute the function. So looking at the code really quickly, when I do my temperature functions here, okay, if I look at my events, when I click on my by value button, I literally just set variables for C and F. I output them before I call the function. I call the function. In this case, I'm not saying ref, so it's just by value. And then I have outputting the values immediately after the function gets executed. The second one is by reference. It's the exact same routine, but I'm going to send it in by reference. So I used a different function because you have to define it separately. So it's a different function. I'll show you those in a second. And you use this keyword ref here to say it's a reference to the variable C, not the variable C itself. It's a reference, so meaning the memory location of. When you go to see the functions, the get by value, you literally just define it with the type and the name, and the value in C gets copied to the Celsius variable, and it gets set here. So if I change the Celsius variable, this will have no impact on C up here. In the second one here, I'm calling it by ref, so I'm receiving the reference to that variable. Okay, so I put ref here and ref here, and when I execute this, this is a reference to C, which becomes equal to the reference of the Celsius, which means that the memory location where this value is stored now just has two names. One is C and one is Celsius. And if I change the value there, both of those variables will change, even though one is in a different procedure altogether. So in this case, when I change the value of Celsius, it will actually, in fact, change the value of C. So the C before and after the function will change. Let's execute this code and show you this actually working. So when I execute this, if I put the temperature 20 in here, okay, and I calculate by value, before the C is a 20 and after the C is a 20. The F is 0 to start, and it does the actual calculation. So 20 degrees Celsius is 68 Fahrenheit. But you can see the value of C is not changed, and that's when we sent it in by value. So if we reset this form, and then I run 20 again, but this time I click by reference, you can see that C went from 20 to 99. So although I changed the variable inside the function, that actually changed the value of C outside of the function. And that's because it was changing the value stored at the memory location of that variable, which was the same memory location as the original variable. So you're changing the original variable as well. And that's why. And again, the Fahrenheit just went from 0 to 68. All right. So that's sort of an idea of that, of the by value and by ref. In C++ courses, you'll learn all about pointers and the complexity of that. And don't think that they don't exist in C#, because they actually do, but we don't cover them because a lot of that stuff is done for you automatically. Literally, by knowing by value and by ref, you can take care of all the things that you would do through pointers inside the .NET framework. So it does make it a lot easier when you're working with memory addresses and those kind of things. The second thing I want to show you is the last topic I talked about before, and that is the concept of variable scope. So the global, the block, and the local scopes. So you can define a global variable here by defining a variable. So I've defined one literally as global var. So we know exactly which ones are global and those ones aren't. And I gave it some arbitrary values, unimportant. Okay. And then within this block of code here. I have it all commented out because it actually has errors in it. So let me uncomment that out because I actually want to use the errors in order to uncomment, not comment, to say, hey, this is accessible here and this is not. So if I get an error, it means that that code that I'm running is actually not available. Okay. So I'm going to go ahead and show you two things. So I've defined two functions here. One, I have the global variable up here. So within a procedure within the same form, my global variable is available. I have no error message here, so it's available. And you can see down here I have error messages, which means they're not available, and I'll show you why in a second. In this procedure, this function, this method, I have an input parameter called input var. That is available within this block of code, within this procedure, as is this variable I've defined inside that block of code. Okay, so that is a local variable that is available within anywhere inside this procedure, including blocks inside of blocks inside of blocks. So all the child code within this procedure will have access to those local variables. This is a separate procedure, and notice that the global variable is still available, but those local variables are not available in the second procedure because these are local scope. This is a different locale. It's a different procedure. So those local variables defined are local to this procedure only and are not available in other procedures. Okay. So if we take this a little further and we look at the fact that we have a block of code, I can define a block of code. I've got a simple little loop here. Let's close this one up for now. A simple little loop here that I've defined a variable counter inside of it, and then I declared another variable here called block var. And you can see that within the scope of this for loop, within this command block, all of these variables are perfectly fine and available. So the global variable, the two local variables, and the two block variables are both available. The counter, although it's not inside this command block, this is really the same command block, so that is a block level scope. And what I can show you is if I go to this code here, which is after this block of code, I'm talking about this block of code here, okay? So I've defined them here. That counter is not available once this for loop is done. So this counter variable here I've declared, once this for loop is done, it's no longer available. And if I mouse over it, the IntelliSense says it does not exist in the current context. As well as this block var that I defined right here is not available. It does not exist because as soon as this block of code ends, this curly brace right here, those variables are wiped out. They're gone. They're sent to the garbage collector and their memory is cleared. So they're no longer available. To go a little further with that, if we put a second control structure within the first control structure, we can have a second layer of block variables. So for this control structure, counter2 and block var2 are block variables. However, for the context of counter and block var1, they're block var, but they're block variables for the outside control structure, which means they're available to all children. So with the perspective of the second control structure, these are actually local variables now, but only local within its parent block structure, okay? But block var2 is available because I've defined it right there. So counter2, block var2 would be available, but only within this control. Block var1 and counter are available within this control, including all of its children, okay? And once we exit all of these control structures, none of them are available. And if I was to add counter2 here as well, which I'll do right now, let's add counter2, it will also have an error. It should pop up in a second. There it is. Okay. So those are not available. So that is global scope, local scope, and block scope. That you may want to rewind and watch again. That's all I got for this video. I'm going to have some more videos shortly with some fairly complex coding that we're going to do to show arrays, algorithms, and functional use. Thank you.